Well, hello, scholars. We are going to be looking at Activity 2 in Chapter 8, and we're going to be looking at uh, we're going to be using the context that we talked about before with this idea of migration, and we're going to be looking at the categorical variable, the percentage of males in this. And remember that the key idea here was for us to, is a majority of the migration is this adult men. So I want to talk a little bit about the sampling distribution and then see how that connects to actually doing the confidence interval for that, specifically the 95% confidence interval. And then later in the next video, we'll talk about the four-step process of how we go about solving a problem like this. So when we looked at this idea before, remember that sampling distributions are really based off of trying to estimate something about a population, in this case a proportion, and we're going to do that based off of a sample. And so those have different symbols, right? Sample proportion versus a sample statistic, or population proportion versus sample proportion. So remember our quotes from our leaders about that time. They were concerned that these were a majority of men, and so the claim conservatively we'll say is that 60% were male. And we said, okay, if this is true, then what is that going to look like? If we take a random sample of 30 people, what should we expect to see? And so we know that if we do that, if the true proportion was actually 60%, we know that the samples would be close to that if if they're random. But in real life, we really don't know what the true proportion is, right? And let's say that if we took a sample of 30 and we only had 15 males, that would be 50%. So the best guess we would have is that the actual proportion is 50%, not 60%. And so, with no other information besides conjecture, if we actually take a sample, notice that sample is going to underestimate theoretically what the true proportion is. So the question is, well, how far off are we going to be, right? So if we go back to assuming that the population is 60%, right? We said that under certain conditions, the mean and standard deviation, right? The mean is going to be the mean of all the samples, and the most likely one is going to be the population proportion, unbiased, and that the typical distance that we are away for a sample of 30 should follow that standard deviation, right? If our population is big enough. Now, if we do that, we consider that it's about 9%, right? So if we think about the normal distribution that looks like this, with a mean of 0.6 and a standard deviation of about 9%, we would expect that the samples that we take of 30 should be off typically from 60% by about 9%. So the fact that we underestimated and we got a sample that was 50%, should that be too surprising to us? And the answer is no, right? Because we were off by 10% when the typical error is about 9%. That's fine, right? So the idea of thinking about what our actual estimate is and then how far off we could be is the idea behind giving a confidence interval as an estimate. So we can give our best guess, which is the sample percentage or sample proportion, plus or minus this margin of error that we think it's going to typically be off by. Okay? So when we think about the 95% confidence interval, I want to use, first of all, we're going to go back to this the data that actually came from Spain here, and we're going to first look at some kind of made up data, and then we'll talk about the actual data that was in there. So if we think about this idea of taking a random sample and figuring out, how many were males that were, 15 or older, and looking at the records here, um, reality tells us that we don't actually know what the true proportion is, right? So if we took a random sample, let's say of 34 immigrants, and of that random sample, 15 were male, right? What we want to know is, based off of that sample, what's an estimate for the true proportion of Madrid's recent immigrants who are male? And we're gonna use this as a 95% confidence level. Remember that our confidence level is how successful the method that we use will be in predicting where the interval that actually has the true proportion within it. So the question is, so what's the true proportion who are male, right? So what's our best guess? Well, our best guess is going to be our sample, right? That's the only information we have. And so if with no other information, 44% is going to be our best guess as to what the actual population is. But the question is, how far off would we expect to be and still be within where that true proportion is? So if we considered all the possible samples, right? Think about all the possible samples of size 34. We would expect that we have some experience with what we would think would be the standard deviation, right? Because we know sample sizes of 34, we know what the proportion might be, so we can do that. And we know that under certain conditions, it's normal if the percentage is not too extreme. The problem is that formula, if you see in green there, that formula requires that we know the population proportion. Well, that's very rarely true. So the question is, well, what are we going to do to replace? What's a decent substitute for that for that variable, right? Well, look above, right? The decent substitute for that variable is the sample percentage p hat. So we're actually going to notice that the notation changes here. And this notation, we refer to it as standard error, not standard deviation, to communicate that we're not actually using the actual proportion. We're using the sample proportion to get us close to what we think it truly is, right? So standard error, you can see it's abbreviated SE, is really the amount of variation that we would expect, typically based off of the sample, not based off the population proportion. So again, these same conditions that we did for the sampling distribution with using the population proportion would still hold true with the standard error. So then the idea here is, notice that the standard error that we would estimate is about 8.5%. So not too much different from what it would be at 60%. So then, if we understand that that is sort of the what we expect the typical sample to be, so now we're going to go 2 standard deviations wider, right? Because that's the 95% method. That's the 95% confidence method, to go 2 standard deviations away from what your sample mean was, or your sample proportion. And notice that we go 2 standard deviations away, that'll cover 95%. And but notice, here's what we're going to do to be more exact, and we'll talk a little bit about this in more detail. But to be more exact, it's not actually 2 standard deviations, it's actually 1.96, because 1.96 is almost exactly 95%. Remember that 2 standard deviations is based off of the empirical rule, and that's really just a way to get us close. So if you go out 1.9 standard deviations, you're going to get about 16%, which means that that actually is going to be our margin of error, right? So plus or minus 16%, or almost 17%. So that's our margin of error. So if we were going to give this as an estimate, we would probably want to give the estimate, as 44% plus or minus 16.7, or we could give it as an interval, right? If you add and subtract that 17%, you're going to get 27 to 61. And so that is where our interval we can actually interpret here and say we are 95% confident that the interval 27 to 60% captures the true proportion of Madrid immigrants that are male. So when we think about this confidence interval that we just created, notice the parts to it. And these parts, we can actually see these on the formula card, but they're given generically. So in other words, they use statistic plus or minus the critical value, which is the how many standard deviations you have to go, times the standard error. And those standard errors are also listed on our formula card, so you don't have to memorize those. But notice, again, if you use the values that we calculated before, you can then give it in either margin of error form, where it's estimate plus or minus margin of error, or you can give it in the interval. Okay, and the interval is another way we can provide this estimate. So really, people provide estimates both ways, and a lot of times in the news you'll see that they just give the estimate, the point estimate, and then they'll kind of put the margin of error sort of in fine print, and then sometimes they'll give the interval depending on the situation. And then obviously the interpretation is something that we've talked about the framework of. So the highlight here of this second part of chapter 8 is really the specific method of creating a confidence interval at the 95% level for a population proportion. So you need the sample from it, and then you need to calculate what that standard error is based off of what your sample was. That is going to be enough that we can find the interval and give an estimate for what the true proportion is of a population.